Hi, good afternoon.
Hi.
Okay. Uh, I'm
Hi,
sorry for
Dr.
the confusion during my previous class. I don't know. I'm continue committing the same error. I'm sorry. I don't know what's happening. Maybe because of early morning, my brain is not completely functional. Anyway, I'm uh, I'm back now. Thank you for coming back. Okay, now let's continue. I'll share my screen with you. If you want to say something, please tell me. Okay. If not, let us start with the class. Yeah, someone want to say anything? Okay. Okay. So let's start from this point. It's exam. Let's see, one tail test and two tail tests. So let's start with the same example we were doing before. We take review. In the previous, I tried to explain in some other way, but I will explain now in a stepwise way, like what are the steps we can take to finish the problem. And then we will understand it much clearer. All right. So first, let me take the ratings. The ratings are like this. So first, I'll take only 50 ratings. If it is more than 50, it's going to be very narrow. I want it to be little broad. It's going to be little wider. So I'll make it 50. I'll explain what is wider, and we already saw that in the standard error, right? But let us see it again. Okay. So what are we doing is hypothesis testing. So for hypothesis testing, first propose a null hypothesis. So our null hypothesis is, let us say that the rating is 8 or above. So that's our null hypothesis. To test this, first we have to draw the Gaussian distribution plot like this, or we call it the bell curve. Let's plot the bell curve. In this bell curve, to draw the bell curve, we need two information. The first information is the mean. The second is the standard deviation. So what is the mean of this curve? It is the center point. And what is the standard deviation? We know how it works. I mean, in the previous examples we saw, if you see in our previous class, one standard deviation takes a 68% of the area. If it is two standard deviations on both sides, it takes 95% of the area under the curve. And if it is three times the standard deviation, it will take 99.7% of the area under curve. Okay, anyway, for all we want to know is we want to know the mean and the standard deviation. So the mean we are going to use is the mean of the null hypothesis. The mean of the null hypothesis. Mean of the null hypothesis. And then the standard deviation is going to be the standard error. Also, we learned in the previous class what is the standard error. The standard error is the standard deviation of the population divided by square root of n, right? So we do that. So we calculate it. For here, for this example, our mean value is 8. So we want 8 or above. So we take 8 as our mean value. I'll explain how it works. It is 8, right? Okay. Now we say we want to know the standard deviation. So we calculate standard deviation of the population. Standard deviation of the population. We don't know. We don't have. So what we can do is standard deviation of, we can do is estimate, right? Estimate of standard deviation, which is like the standard deviation of the all the samples we have. So what I consider this data is not the population, it's just a sample. So because there are more than 1,000,000 people has watched this series, but only 1,000 people's information is available here. So I consider it as a sample. So I have a sample here, right? So this is the sample standard deviation. Okay, we have so what we want is standard error. What is standard error? Standard error is equals to standard deviation divided by square root of the total number of samples. I mean sample size we call it, the number of elements available in that sample. So we call it as the, we can use count to count that. We count all of them. Okay, so what we do next? So we have mean and we have standard error. Standard error is the standard deviation for the bell curve. So let me write this. Standard deviation for the bell curve of is the standard deviation used for the bell curve is the standard error. So we have the standard error. So we know everything. So we can plot it. I was telling before, I don't want, okay, we already removed it to 50, right? Yeah, because if it is a lot of numbers, it's going to be very narrow. Let me show it how it becomes narrow. So for example, if we take all the 1,000 samples, we divide it by, so it becomes 0.07. So the standard error is very small, and which is very, very good for in the real life conditions. But for explication purpose, for the explanation, I'm unable to pronounce this today. Explication purpose, I want it to be little bigger. So I will take only 50 samples for this purpose. So I have this. Okay, so what is the procedure? Now pay more attention now. Let us see the procedure. So we say 8 or more is the null hypothesis. We leave null hypothesis in white and we paint alternate hypothesis in red. So the alternate hypothesis is going to be 8 or less than 8, right? So let us draw this. 8, sorry, it's less than 8. So it is all the plot less than 8. It's going to be this side. This is true, but here we are not considering the type 1 error because there is a possibility of type 1 error. So to consider type 1 error, what we have to do is we have to minimize the type 1 error. How do we minimize? So the type 1 error gives probability of making that mistake type 1. So we call it the significance level. So we have to decide how much significance level you want. Significance level is also called p-value. It's also called alpha. It is also called probability of committing type 1 error. So what's the probability of committing type 1 error? We can put it here, how much error is acceptable. So we know it should be very small number. Let us say it is 5%. 5% in probability terms we say 0.05, right? So it is 5%. So we can't draw a line here and paint all this. We have to paint only 5%. We don't want to paint all this. Only 5% is possible error. So we just draw a line such a way that the area occupied is only 5%. So we fill this area such a way that it is the painted area in red is only 5%. So it is 5%. And all the white place is 95%. This one we call it one tail test because we have tail only one side. The red one is we call tail. So we have on this side. So this tail can go the other side, the other way. Why? How? It can go instead of, I mean, here I'm saying the rating is 8 or above. If I say 8 or below, the the alternate hypothesis is going to be the opposite, and it's going to be the other side painted, right? So what are we actually painting? We are painting the alternative hypothesis. What is alternate hypothesis? The rating is less than 8. The painted region is alternate hypothesis. Remember, the alternate hypothesis and null hypothesis are opposite. So if this white region is null hypothesis, the painted region is alternate hypothesis. So we always paint in red the alternate hypothesis, and which you consider as the tail. So here we have left tail. So the tail will go right side if we have the rating more than certain value, like more than 8. If we say, it will be like the tail will be going on the other side, right? Okay, anyway, now this is the problem we have. So we have only one final step remaining, or we can say two final steps. The first step is we painted this, but we know the area here 5%, but we don't know what is this value here. We have to find out this value. So this is we have to find. So how do we find? By applying the inverse of the normal transformation. Sorry, normal distribution. So normal distribution inverse. So the probability is, we know the probability is 0.05, and the mean, we know the mean is 8, and the standard deviation also we know it is the standard error, which is this one. So how much it is? It is 7.6. So this value here, it is 7.6. So we got this value 7.6. So the one final step is remaining. The final step is calculate the mean value of the sample. We calculate the sample mean, and if the sample mean falls in this red region, if it is in red region, it means it belongs to alternate hypothesis, means we reject the null hypothesis. If it falls in white, we fail to reject the null hypothesis. So we have two possibilities. One, if it falls in the red region, it means the alternate hypothesis won. So we say we go with the alternate hypothesis, or the correct word is we reject the null hypothesis. The other case is it falls in this white region, the white area, and then we call it, so we call it, we failed to reject the null hypothesis, or in very informal way of saying, we accept the null hypothesis. So the final is, so this is the limit. I call it limit, this limit, right? So what I want to know is the average or sample mean. So what is the sample mean? The sample mean is equals to average of the sample, which is 7.8. So where does the 7.8 falls? In the red region or in the white region?
White.
In the white region, right? Yeah. So, okay, let me write here. So sample mean falls in the white region. So what do we call this? I mean, what option are we selecting? We reject the null hypothesis, or we failed to reject the null hypothesis?
Fail to reject?
Yeah, in informal way, we accept the null hypothesis, right? Yeah, we failed to reject the null hypothesis. We failed to reject the null hypothesis. Okay, now I'm gonna make more. I want to complete the whole. Now we understood. So now I want to make it complete. I mean, use the complete information we have. It's more accurate, right? So let me.
Could you please maybe just saving that sheet and before starting completing the sample, doing it in another sheet?
Okay, you want to make it another sheet. Okay, this is a
Yeah, please.
sample of 50. Sample of 1185. Okay. So sample of 1185, we copy the complete one, right? Okay, and here hypothesis testing for 1185. Here some hypothesis testing for 50. Okay. So here we use, instead of 50, we use 1185. Instead of 50, we use 5. Here is the same. Here it's the same. Here it is the 1185. Okay. So the next one says, if I keep the same graph again, let me draw another one. Here again, we go 8 here. We draw a red line. And this is 5% of the area, and the remaining is 95% of the area. And here the limit I calculated, we calculated it is 7.9. So it is 7.9. So what is the value we are getting? 7.3. Where is the 7.3? Where does it go? In the region, red region, or in the white region? 7.3. I just changed the values to the new information. So I got the sample mean of 7.3. Where does the 7.3 goes? In the red region or in the white region? In the red region, right? Very good. Yeah, because it is here. It is somewhere here. So it is in the red region. So if it is in the red region, what are we going to do? We're going to reject the null hypothesis, or we're going to fail to reject the null hypothesis. What's going to happen?
Reject.
Yeah. So here we sample mean falls in the red region, and we reject the null hypothesis, right? Okay. Is it clear? Any questions? Do you have any questions? If no, we go to the next part. Okay, no questions at this moment. So we saw one-tailed test. Now let's go for the two-tailed test. So what is a two-tailed test? So if you see here, the one tail is coming because if it is, we say if it is less than or more than, so we are selecting one side of the area. So the other side, it looks like a small tail, right? Now let me save this. We call it one tail test. Now let us do another example. I will take example of the Titanic disaster. The Titanic disaster, we saw some information. I'll try to compile some information. For example, this is the information of how many people survived. So we can see it is kind of a sample because this information is not complete. So what am I interested here is I want to know, I want to do some analysis, or I want to propose some null hypothesis based on the number of, the average age of the passenger who are dead. So I take all the passengers who are dead and I want to know what is their average age. So the average age of the dead persons dead because of the Titanic disaster, right? So how do I calculate? I use this Excel sheet to calculate. 1 means survived, 0 means unable to survive, so they are dead. 0 is like they are dead. So I want to take all the dead people here, the ages of all the dead people, right? So this is the age of all the dead people. So I'll put it in another page. So what I have is a sample of all the people who are dead in the ship. So there are around 400 people I have. I can call it as a sample because it's not the complete list. So I have some ages. So it's the research I have done, right? So age of passengers dead. So it's just age I don't want to give more information because it won't let me type a lot. So age. Okay. I'm going to propose something. So it's age. I'll put 1 and 2 because I also want to do like before what I did. I'll put for 100, age 100. And another one is I'll keep it age. When I say age, it is complete information. When I say 100, I want to take only first hundreds. I mean only 100 sample elements. The sample size is 100. When I say age, it's the complete one, right? Okay. Here I do hypothesis testing. For 100. Hypothesis testing for 100. Okay. So what do I want to do? So I want to propose some null hypothesis. Does anyone want to propose a null hypothesis with equal sign in it? Or I can say, let me ask, can someone of you guess what is the average age of the person who is dead on the Titanic ship?
50 years.
50? 50 or
Yes.
15? 50? Okay.
No, 50.
50. Okay, so what you're proposing is mu is equals to 50. Mu is the average age of the person who is dead on the Titanic disaster. Okay, so alternative hypothesis is mu is not equal to 50. In other words, what can I say? Mu is more than 50 or mu is less than 50. So if you notice here, I'm saying the mu is more than 50 or less than 50. So I have two tails, you see. So I'm selecting on the both sides. So that's why it is called two-tail test. So let me draw this. So let me, okay, if I have here, so the average age is, we know, we know the null hypothesis is 50. So we say 50. But I'm saying, the null hypothesis, the alternative hypothesis says we select all the area which is less than 50 and also which is more than 50. So only the 50 is null hypothesis. The less than 50 and more than 50 is alternate hypothesis. But we don't want to make it so big. We want to make the error very less, right? So how do we do that? We propose some error. So what is the error? So I will copy, I closed it, so I'll type it again. So significance level or alpha, p value, or what's the final one? Probability of committing, or is it probability of error type 1. So whatever you say is the same thing. So how much we want? Let us say we want it to be 90%. Sorry, the error should be less. So it should be 10% of error. So I say 0.1, right? So we have 90% confidence or 10%. Or let me change it, not, let me, I didn't want to use 10 because if you make half of the 10 is going to be 5 and 5 is going to look same like the before, right? So I don't want to make it look the same. So I'll change to some other number. So let us say you want with a 98% of thing, or you want to say 2% of error. So you want only 2%. So 2% is 0.02, right? So the type 1 error allowed or the significance level is 0.02. So we can't paint like this. So we paint the region which has this side and this side like this. We have two tails. Okay. It will be always symmetric. I'm not drawing correctly because I don't know why, but let me try. Okay. This will be always symmetric. Okay. So the area here and the area here together is 2%. So what I want to say here, it is 98%. If it is 98%, it's going to be 1%. It's going to be another 1%, right? So these are the tails I'm talking about. Okay. So what I want to know, I want to calculate this point and this point. So once you know these points, so our problem is complete. Okay, to know these points, we have to define the curve proper with complete information. The information missing is the standard deviation of this curve. The standard deviation of this curve is the standard error. The standard error is we have to calculate. So let us say standard deviation of sample is how much? Standard deviation of the sample is this much. So standard error is this one divided by count of, sorry, it's a square root of count of the complete. Actually it is 100, so 100 square root is 10, so it's going to be exactly 10 divided by 10. Okay, it is correct. So now we have standard error. So we completely define this graph. So we want to know. So this, I'll call them, I'll give some names to them. So I'll call this the lower limit, and I call this the upper limit. Usually in mathematics, we don't use this like this. We use the limit. In subindex, we say lower. And here we say limit, subindex, we say upper. So it's easy for us because L means the limit. The another L shows the lower limit, another U represents upper. So I say limit lower, limit upper. Okay, the lower limit is, so if you want to know the when we take inverse in the Excel, it is doing inverse of the cumulative distribution function, right? So what we are saying, we want to know the cumulative probability. The cumulative probability here it is 1, and here it is 99. Why? Because you have to add all the area on the side of this. So all the area left side of this is 1. Here it is 98 plus 1, which is 99. So here it is 99%. Okay, it is, let me type it. So it is 99%. So we calculate upper limit, lower limit, and upper limit. So lower limit cumulative distribution function is 1%. 1% is, let me say 1%, and upper limit cumulative density function is 99%. When I write percent, it actually takes 0.01. So if I say, and if I use without percentage, if I remove the percentage, it will show 0.01. That's why I'm getting it. Okay. So let's apply the cumulative inverse of the cumulative distribution function. Say normal distribution inverse. So if you want to do, what is the probability? 1%. When it is 1%, and the mean is, we know it is 50, and the standard deviation, we know it is 1.58. So it is 46.31. So let me copy and paste it here, and here I take 99. So I'm getting lower limit and upper limit. So the lower limit is 46.3. So here it is 46.3, and the upper limit is 53.7. So the one final step is remaining. We calculate the sample mean. If it falls in the red region, we reject the null hypothesis. If it falls in the white region, we fail to reject the null hypothesis, right? So we calculate mean sample mean. So the sample mean is 29.4849. So the sample mean is 29.49. So what does it mean? It falls in which region? 24.49. Where does it fall? The red region or in the white region?
In the red region, because it is lower from the lower limit?
Yeah, it's less than the lower limit, right? Very correct. So it is somewhere here, very far away from this. And it falls in the red region. So what do? We reject the null hypothesis, or we fail to reject the null hypothesis.
We reject.
Yeah, we reject the null hypothesis. So we reject it, right? Okay. So any questions in this? Okay. If no questions, we'll continue the same with little more information, or we can say the complete information we have, complete information available to us. So it is hypothesis testing. Let us say full representing the full hypothesis testing full. So what we do this same, keep the same here. I just remove the part of 100. Here remove 100. Okay. The new lower limit is 48 and the upper limit is 51. And the sample mean we are getting is 30. So what do? It is in red region or it is in the white region? Where is it? Where does it belong? This sample mean. So
it's still in the same red
region.
Yeah, it's still in the red region. Yes, because here the number is updated to 48 and here it is 51, or we can say this region actually it is coming little closer, means we are further away from the before, so we are like very far away. Anyway, so we know it's in red region and we are rejecting the null hypothesis, right? It is yeah, Claudia, please ask.
Thank you. I have a question, doctor. In case, for example, the sample mean perhaps was bigger than the lower limit, in this case it was wide region, and then we can say that we failed rejecting the null hypothesis, or it's still the same question, the same answer.
I didn't hear properly. Please repeat the question again, please.
Yeah, what I was saying is that in this case, if the sample mean was bigger than the lower limit, and also, no, I mean, it was bigger from the lower limit, and in this case, it was in the wide region, it's still the same, reject the null hypothesis, or in this case, we failed rejecting the null hypothesis.
Can you give numbers because the big and small I'm kind of confused. For
Okay,
example,
for
here,
example, in this case, the sample mean it was, I don't know, 52, because it
mhm.
is bigger than 48, so it's in
Okay.
the wide region.
No, 52 is not in the white region. I'll
Okay.
explain you. Because if you say 52, let us say 52. Let me change these
So
values.
let's say it was 49, which it is in the white region.
Oh yeah. So if it is 49, then we fail to reject it. Let me see these values. 48.4. That is 51.6. Okay, for example, if it is 49, 49 falls somewhere here, right, in the white region. So if it is in white region, we fail to reject. So if it is here, this region is called fail to reject null. Right? Was it your, is that your question?
Yeah,
Claudia?
it was my question. Thank you very much.
Yeah,
Yeah, it's much clearer.
yeah, you're welcome. But if you see 52 in this case, it is going this side and it is a two-tailed, so it is going to be again in the red region. So it is 49 is a good example. So 49 falls here and 52 falls very far from here. So it is again here we reject it. Reject the null. And if it is that, and if it is 30 again, even if it is 30, we again reject it. Only values between 48.4 and 51.6 we fail to reject. For remaining all values, we reject it.
Oh, okay. Thank you very much.
Yeah, welcome. Any other questions? That's all for today. If you have questions, you can ask me, or else we can
Yes,
conclude for.
Professor. Well, we have some questions on the
Yes,
homework.
yes.
Can we check them?
To the homework. Okay.
Well, I also need you to help me including me in the correct group in Blackboard because I cannot do that by myself. I have to be on the group 1 because
Okay.
we are already working on the homework.
But which
And
group you are added to?
sorry,
Which group are you now, right now?
I am
maybe we'll
now
have.
in the group 2, but I have to be in the group 1.
Okay, I will see that part. Wait, let me stop this recording.